Hi everyone, in this video we are going to tell you how to interface an RTC or a real-time clock module with Arduino. So for those of you who don't know what a module is, modules are nothing but external hardware which can be attached to your Arduino to add additional functionalities to it. For example, you want to sense temperature with your Arduino. There's no inbuilt sensor in Arduino which can do that. So you attach a temperature module with an Arduino which senses the temperature and sends signals to Arduino. This way you can add various functionalities to Arduino. You can add Wi-Fi, Bluetooth, SD card, a real-time clock of course. And so in this video we are going to tell you how to interface this RTC, a real-time clock. Now what it is and why it is used is what we'll cover now. So here's what an RTC module looks like. It's a chip, it's a breakout board with a chip in it. And the back of the chips looks something like this. It has a coin cell attached to it. Now what is the use of RTC? RTC is used for keeping time for our computer chips and for our microcontrollers. Why do we need a separate chip for that? Now suppose you have your desktop. Now you know on your desktop there is a clock which you can see on the taskbar usually. Now when you switch off your desktop, you are disconnecting every other power supply from it. And now when you switch it on, you see the clock still shows the correct time. So how does the laptop or the computer or desktop keeps time instead of being powered off? There are many ways of doing it. Nowadays devices do it also with what you call GPS and internet. But usually in olden days when the net was not so widely popular, people used these kind of chips called RTC chips, which were inside the microprocessors, and they kept a record of the time. Now when they switched off your what you call the main power supply, this chip has its alternate power supply. In our case, this power supply is a 3.3 volt coin cell. So when even when the power switch is off, this chip would still keep the correct time in spite of Arduino malfunctioning or power failure or anything else. So you power the Arduino up, set the time, and when you power it again, it will still show the correct time. So now let's go on to the coding section for it. So the RTC module that we are using, that is DS1307, belongs to a special kind of RTC. It belongs to a special kind of category of devices called the I2C devices, or I2C. I2C stands for Inter-Integrated Bus. What is I2C? It is nothing but just a protocol for data transmission. You know what a protocol is. Let me give you some examples. So Wi-Fi is a protocol, a Bluetooth is also a protocol for wireless transmission. Similarly, USB is a protocol for wired transmission. Similarly, I2 is a protocol that was developed by Philips Semiconductors, now known as NXP. And this protocol has some definite rules which will help us to program this RTC module. Now in this tutorial we won't be telling you just how to program RTC module. There are several other I2C devices like EEPROM, sensors, analog to digital converters, which you can program using this I2C protocol. So we will be covering I2C protocol in general and RTC in particular, but this will also give you an exposure how you can use other devices using pretty much the same coding language. So let's start with the essentials of the I2C protocol. I2C protocols consist of a master and several slaves, as you can see out here. Master in our case is our Arduino, and the slave is our RTC module. Master and slave are connected by two lines, SDA and SCL. SDA is called serial data and SCL is a serial clock. The master generates the serial clock and it sends data through this SDA line to and from the slave. In case it's a sensor, then from slave. So in case of our RTC module, suppose we want to write time onto the module, we will use the microcontroller. The master microcontroller will send the data into that RTC module, and if you want to read time, it will take data from that module through the SDA line only. If you have a look at the pins on your RTC module, which I have shown here, there are SDA and SCL pins out here also. So these correspond to the above two pins in the I2C protocol. Now, there are other pins like VCC and ground. VCC will connect to power supply and ground will connect to ground. I'll show you later how to connect this RTC module to your Arduino. Now, there is one additional pin called DS pin. This DS pin is an additional functionality of the RTC module, which we won't be using in this tutorial. It's called the square wave pin. The thing is, this module can also make square waves for us as an output, but we won't require it for this tutorial. So let's keep it away for a while. Let's get back to our I2C protocol. As I told you, there is one master and there are several slaves. These slaves have unique addresses. So master, what it does, it sends an address to the slave acknowledges that address. As each address is particular to one slave only, you can control all these devices independently using one single master. That's the beauty of I2C protocol. There are other things, other very essential features of I2C protocol, which we will be covering in when we program this thing. But first, let's have a look at the circuit that we are going to make. To connect it to your Arduino, the first thing you have to do is attach VCC to +5 volt out here on your Arduino and ground to ground. Now in Arduino, there are special pins dedicated for SDA and SCL. That means these SD and SCL will pretty much not work on other pins, but work out here only. So SDA should be connected to the analog pin 4, that's A4 on your Arduino, and your SCL should be connected on analog pin 5. There's no need to connect other pins like DS, square wave, or battery, other things like that. So this is pretty much simple, just 4 things which you have to connect to your Arduino: ground to +5 volt, plus VCC, ground to ground, plus VCC to +5 volts, SDA to pin A4, and SCL to pin A5. You can use it from this side of the board too. Okay, now let's have a look at the program. So open up your Arduino IDE, that's the integrated development environment, and start typing this. Firstly, include the library wire.h. What is wire.h? This is a library for Arduino that implements I2C protocol. This library has inbuilt functions, inbuilt features that allow you to use the I2C protocol very easily. Next, define a variable RTC 0x68. So 0x68 means 68 in decimal, 68 in hexadecimal. This 0x means that 68 is a hexadecimal number. Now what is this? Why are we doing this? We have defined a variable named RTC with this value. So this, as I told you earlier, I2C protocol has a specific address for each and every slave that it is attached to. So our RTC is a slave and it has this address 68 in hexadecimal. How do we know this? This is the address. If you look at it up in the data sheet of your RTC module, you'll find that this is the address given. This is predefined for our RTC module. Now the other thing that's very important to know, your RTC modules stores data in the form of binary coded decimal BCD numbers. If you don't know what is a BCD number, just pause this video for a while and Google it. So it uses BCD numbers to store data. Now in order to read data, what we have to do, we have to convert those BCD numbers to decimal numbers. How do we do that? So we write a function out here. It's a return type function byte, and we call BCD to decimal. So this number, what it does, it converts converts a BCD number to a decimal number. So we can, if there is time stored in your RTC module, you can read it in decimal form. Fine. It takes in an argument named byte value, and it uses this function. This function takes in value, divides by 16 into 10 plus value mod sin 16. How do we get this number? That you go and look it up on the web, because I mean you don't need to know, you just need to know what this function does. What this function does is that it takes in a BCD value and converts it into decimal so that it's readable in the general form. We need one more function, a similar function that would convert decimal to BCD. Suppose we want to reset the timing of our clock. So what we do, we input a decimal number and then we change it to BCD and store it in the RTC module. So this function is used for that purpose. So here is the formula for converting decimal to BCD: value divided by 10 into 16 plus value mod 10. Pause this video for a while, type this formula. You don't need to know what it is, but if you are curious, you can check it up on the web. Now, the first thing which we do is we write a function to read time from our RTC module. So define a function named void read time. Also, we will define a function named void set time, and also a function named void display time. Now, what have we done? We have three functions. These will generate, or these will read time, set time, display time. We will tell you what to write in these functions in a while, but first let's go to the setup loop. Also put these opening and closing braces after these functions. Just gives them a more professional look. Looks better. So in the setup, write wire dot begin. This means we have asked the while library to start functioning. Also write serial dot begin and 9600 is our baud rate. So what is serial dot begin? Suppose we want to use serial monitor in Arduino. You use this. Now what is serial monitor? Suppose you want to display the data that is collected by your Arduino or your sensor or something on your computer screen. So this serial thing will display that data on your computer or laptop screen. I'll show you in a minute what it is. Now if you look at the top right hand corner of your Arduino IDE window, there is something called serial monitor. When you press this button, it opens up a new window. This is called the serial monitor. What happens, suppose you want to send data from your Arduino and display it onto your computer. So this thing can be used. So in this program you will also learn how to use this serial monitor. You can use it for various other purposes too. Okay, let's get back to our program and write our first function, that is read time. So the RTC module stores all its information of timing in specified registers, and we want to read those registers. So mention these as arguments to your function. So it contains byte, second, byte, minute. I mean these seconds and minutes are variables and byte is the data type. Similarly hour, day, date, month and year. So this RTC module keeps a record of all these variables: second, minute, hour, day, date, month and year too. Notice this, there is an asterisk sign before each one of these variables. Why is this there? It's because the information in the RTC module is stored in registers, and in this language, when you have to point to a register, we use this symbol before the variable. So these are basically pointers to the registers inside our module. Remember, these are pointers to the registers inside our module. Now write this statement: wire dot begin transmission. And in the argument mention RTC. What this statement does, that it begins transmitting of data to this RTC module. Now write wire dot write 0. Now whenever you have to read something from your module, you have to actually first write something to it. Write something to it in the sense you have to send a signal that we're going to read from you. So this thing goes into your module. Now I write wire dot end transmission. After this, write wire dot request from RTC 7. What this statement does, that it requests 7 bytes of data from our RTC module, that is from the address 68 which we mentioned above out here. Why do we write 7 out here? If you have a look, we have 1, 2, 3, 4, 5, 6 and 7 variables out here which we want to read from our module. Hence we write wire dot request from RTC 7. So we request 7 bytes of data from RTC. Now we start reading data from our RTC module. So let's read seconds. Second is equals to wire dot read. Similarly, you have to do similar things for hours. Minutes first. Equals to wire dot read. Also remember one thing, the information inside is stored in the form of binary coded decimal, BCD numbers. We have to convert it into a decimal. Remember the function we have used here before, mentioned here before, BCD to decimal. We have to use this function now. So we write BCD to decimal and we pass wire.read as an argument to that function. What we have to do, so what it does out here, it reads the first register which is in BCD and converts into the decimal and stores it in the second. You have to do the similar thing for minutes to BCD to decimal and wire.read. Similarly, we have to do this for all these 7 variables and in proper sequence. So here's how it looks. So now we have all the 7 variables in proper sequence. Remember that sequence has to be proper. We have to have second first, minute first, hour, date, month and year, because our program doesn't know in what order are these numbers stored inside those registers in our module. As I told you that if we read it from registers, so the first register is second, then it's minute, and then hour, and then day. So all these have to be read in sequence. So it reads first register, stores it in second, reads second register, so stores it in minute, stores the third one in hour, and so on and so forth. Suppose you want to know the sequence of registers in your RTC module, what you can do is open up a data sheet of that RTC module. I'm going to open up that now and show it to you. So you can download the data sheet from the web and search for timekeeper registers in those data sheets. So here is the data sheet of DS1307 with timekeeper registers. Now right here you can see there are like 8 registers. Now these are the addresses of the registers 0001, 02, 03, 04, and here is the function of the register, that's seconds, minutes, hours, days, date, month, year and control. So if you have a look at this, there are 8 bits 0 to 8 in all the registers. This was a 8-bit binary coded 8-bit which I was telling you about earlier. Now let's have a look at this seconds register, which is the first register, and remember the sequence, seconds, minutes, hours, day, date, month. It's the same as we wrote in the program. So the program reads these registers one by one, stored in consecutive addresses. Seconds register 0 to 4 bit represents seconds and 4 to 6 bits represents 10 seconds. What does that mean? Suppose we have 23 seconds. So 2 will be stored out here and 3 will be stored out here in these 4 bits. 2 out here and 3 out here. Suppose it's 36 seconds, then 3 bits, number 3 would be stored in these 3 bits and number 6 would be stored in these 4 bits. There is one more thing which we have to take care of. You see that all the bits in this register do not show seconds. I mean, the 7th bit, if you see bit number 7, shows something else, and we don't need this. So we have to somehow eliminate this reading from our seconds variable. How do we do that? Just write and 0x7f. So what is 0x7f? If you just write it in binary, it seems you have to write 7. 7 is 0, 1, 1, 1, and you have to write f. 1, 1, 1, 1. This is 7 and this is f. We ANDed it with 07FF. What does it do? It automatically ANDs that bit 7 which is out here with this 0 and makes it 0. So that bit doesn't have an influence on our seconds variable. Suppose the CH out here is 1, then that CH would also contribute to this reading of our seconds, but we don't want that to happen, so we write 0 out here. Similarly, we write 0x3f at r's digit. What is 3f? It's 0, 0, 1, 1 and f 1, 1, 1. So these two bits are being ignored. So what do these correspond to in the registers? If you have a look at this thing out here, it's these two registers. Firstly, bit 7 which is being ignored, and second is the format. So these bits are used to control the format, 12 or 24-hour format. As I told you, we're going to use 24. We are not going to use this bit. That means only these bits, bit number 0 to bit number 5, will show the number of hours and not this bit. And so we have eliminated those bits in our program by ANDing it with this hexadecimal number. So here it's done. We have read all this information, and now what we have to do, we have to display this information so we can use it. So go to the display time function that we created earlier and write these lines. Firstly, again make variables second, minute, hour, date and time, month of the year, and then call the function read time as such. So when variables refer to pointers, you remember we declared all these variables as pointers out here. So when variables are used to access pointers, we use this symbol out here. And what it does, it calls the read time and reads those pointers into these variables. Now we have all our information stored out here. Now what we have to do, we just have to print it. We'll use serial monitor, serial.print. We'll print hours first, then serial.print, serial.print a colon as it is displayed in the watch, serial.print minutes, and you can print other stuff too. Let's print second now. So it's hours colon minute colon second. Let's just paste this stuff out here. Second, and then you can print your day, date, etc. Let's say day, and here I have printed what you call after the day, the date and the month and the year. So you can do this. You can just print these two if you are checking the stuff. So in this program we have done nothing. We have declared variables, called that function and just printed those functions. Now what we have to do in your loop is you have to write, it's call this function display time, and then you have to give a delay of, let's say, 300 milliseconds. So what does it do? It calls on the display time function after every 300 milliseconds. That's it. So now we already have made the circuit. Now just plug in your Arduino on the board and start programming it. I just made a trivial mistake in the program. Just when you have defined the RTC, do #define RTC. Yeah, that completes the program. So after connecting your Arduino, when you compile the program, you'll get the following errors. So these are certain typos I made, so just correct them with me. So when you define, you have to use a hashtag, not a hashtag, it's just hash. And in the BCD to decimal, I've declared the variable as value, but I've used val, so just do that. Now there's one more error which I have done. It's towards the end of the code. That's when I call the display time function. I have to make this capital. Yeah, fine, that's it. Now when you compile it, it will compile definitely. Now just upload the thing to the board, and here you see it's uploading. And after uploading, when it says done uploading, just go to the serial monitor and you will see something like this. You see that? So that's seconds, that's hours, that's minutes, sorry, that's hours, that's minutes, that's seconds. So it's, you see seconds changing, 52, 53 and 54. We forgot to mention a space between the day of the week, so it's 1 out here. Okay, so it's 1 minute now. See the changing. So the day of the month and the year, it's what we haven't mentioned. So now we'll see how to set all these variables in. Suppose you want to set a particular time in your RTC, how to do that. So let's go ahead. Go to your set time function that we created earlier and mention those variables again. Byte, second, byte, minute, byte, hour, byte, day of the month, byte, oh sorry, it was day of the week, byte, then date, byte, month, byte, year, and that's done. So remember that we write in the same sequence as we read. That is, we read it in the same sequence, like byte, second, byte, minute, hour, and we read also in the same sequence because registers are the same whether we read or write. Now we begin as before, wire dot, remember this, begin transmission and RTC. So begin transmission with RTC, and then wire dot write 0. Now here's where the protocol comes in. Whenever you have to communicate with the board, you have to write these two statements, wire dot begin transmission, wire dot write, whether you read or write. So firstly we write 0, and that is a part of I2C protocol. Now we start on writing the time, let's just seconds. So wire dot write, and then you write seconds to it. Now you know that we cannot write as second as such because the registers store numbers in BCD format. Then you do decimal to BCD conversion out here, and the function which we created earlier out here, decimal to BCD, will be used. So what this thing does, that it converts the value stored in the variable second to BCD and writes it to the second wala register which we mentioned earlier. Similarly, do it in the same sequence for minutes, hours, date and month and year, because the registers appear in the same sequence. After doing this, write wire dot end transmission, and you are done with the code. Now we have to call this function in our our setup. Why do we call this function in our setup? Is because we only want to set time once. We don't want to set time again and again. So what we do, as you know, that setup executes only once in your microcontroller. So we write in the setup and enter the parameters. So second was first, so let's say 20 seconds, 4 minutes, 6 hours, and let's say 6th day of the week, and then say, let's say, second month of the year, and then the year itself, let's say 2016. Fine, so let's verify our code. Okay, I think I missed some variable. I missed the date. Okay, so the date, let's say it's 7th. Let's verify it. Yes, done compiling. Now upload it to your board, and now it's done uploading. Let's see what the thing has to show now. There's it. 6 seconds, 6 hours, 4 minutes, and seconds are changing. Here is the day of the week which you mentioned, that was 6th. 7th is the date, month, and 2016. That's how you do it. In case of doubts or suggestions, please mention a comment in the comment box. Also try to play around with it and see what all can be done. Thank you.